to network communication models. So why do we need network communication models? The first reason is that network models specify how data, which is electronic information, should be packaged, addressed, transmitted, routed, and received on an end-to-end data communication link. The second reason is that they reduce complexity and make it simple to teach and learn or understand how data networks function. 3. They encourage standardization and facilitate modular engineering. 4. They promote interoperability between different vendors. And 5. They support and accelerate research and evolution. So network models are structured into different levels, which are called layers. So next we are going to see the two main types of network models. So there are two types of network models. The first one is the OSI model, and the second one is the TCP/IP model. OSI model means the Open Systems Interconnection model. The OSI model was developed in 1984 by the Open Systems Interconnection Group at the International Organization for Standardization (ISO) and the Internet Engineering Task Force, which is IETF, to support the emergence of the diverse computer networking methods that were competing for application in the large national networking efforts in France, the UK, and the United States. The TCP/IP model, on the other hand, means Transmission Control Protocol, Internet Protocol Model. It was developed and funded by the United States Department of Defense, DoD, through the Defense Advanced Research Projects Agency, DARPA. The TCP/IP model is also called the Internet Protocol Suite. So you can see the link on Wikipedia where we got that information. So let's start with the OSI model. The OSI model consists of 7 layers, and each layer performs a particular network function. So we can see the 7 layers we have in the OSI model, starting from layer 1, which is the physical layer, layer 2, which is the data link layer, layer 3, which is for networking, layer 4, which is the transport layer, layer 5, which is the sessions layer, layer 6, which is the presentation layer, and layer 7, which is the application layer. So it's good to memorize this and understand what goes on at each layer. As a network engineer, basically we'll be dealing more with the layer 1 to layer 4 because this has to do with routing, switching, and also transmission of data within the physical links. So let's look at how these layers perform and how they operate. So we'll start with layer 7, which is the application layer. So the first layer where data is created and is sent from is the application layer. Why? Because at this layer, this is where the user has interaction with the host computer or device. So imagine you're sending an email or you're typing in a text document. Usually you would enter data into the application. So it's going to be sent from the layer 7, which is application layer, down to layer 6, which is the presentation layer. And when it's being transferred, on the other end, it will also come from the presentation layer back to show the user at the other end on the application layer. So let's take note of this, that the application moves down to the presentation when sending, and when receiving is from the presentation layer to the application layer. So this is a summary of what takes place in the application layer. We can see that it serves as a window for user and application processes to access network service. So we can also see other functions like file transfer, access management, and management, that's FTAM. which the application layer allows a user to access the files in a remote computer, to retrieve files from a computer, and to manage the files in a remote computer. And we also have mail services and directory services. So the main thing to understand about the application layer is that it involves the user interaction. So it's the first point of data creation and beginning to be transferred. So then we have layer 6, which is the presentation layer. So data moves from the application layer to the presentation layer. And we can see here from diagram that it's involved with encoding, encrypting, and compressing data when sending, and the presentation layer at the other end is involved in decoding and decrypting and decompressing data when receiving. So what are the things we can notice from the presentation layer? We can see that it's mainly concerned with the syntax or semantics of the information exchange between the two systems. It acts as a data translator for a network. The layer is part of the operating system that converts the data from one presentation format to another format. The presentation layer is also known as the syntax layer. So when you create a PDF document, for example, that takes place at the presentation layer. So we can see other functions, which is the translation and encryption and compression. So now we have layer 5, which is the session layer, and this takes place after the presentation layer. So the data from presentation layer is transferred to the session layer. So what can we see from the session layer? We can see that it's actually a layer 5, not a layer 3 in the OSI model, so that's a mistake. The session layer is used to establish, maintain, and synchronize. This is the interaction between communicating devices. So we can see two functions of session layer, which is the dialog control, and we can also see synchronization. So we can see that the session layer is very, very important. So then we have the layer 4, which is transport, and the transport layer receives the data from the layer 5, which is the session layer. So from here we need to take notice of how the data is represented, because from layer 7 to layer 5 is represented as data, but in layer 4 you will see that it's going to be represented as a segment with a layer 4 header. And this is what I was talking about, and I said at the transport layer we have what we call the segment. So what happens here is that the payload or the data, which you can see at the end, right end of this diagram, is the data from layer 5. And remember, it first starts from layer 7, then moves to layer 6, then layer 5, and that's when it is sent to layer 4, which is the transport layer. And we can see that a TCP header is now added to the payload, which is the data from layer 5. And we can see that when the TCP header is added to the payload, is called segment, which, as described there, is a chunk of data with a transport layer header. So let's take note of that. Let's also take note that the source port is the first portion of this segment, and you can see that the destination port is the second area of this segment. And we also have flags, sequence number, acknowledgement number. So let's take note of this. Source comes before destination. So in layer 4, we can see that it ensures that messages are transmitted in the order in which they are sent, and there is no duplication of that data. The main responsibility of the transport layer is to transport the data completely. It receives the data from the upper layer and converts them into smaller units known as segments. This layer can be termed as an end-to-end layer, as it provides a point-to-point connection between source and destination to deliver the data reliably. So we can see two protocols are used in this layer. We have the TCP, like we saw the TCP header attached to the payload. So we have the TCP, which is Transmission Control Protocol, and we have the UDP, which is the User Datagram Protocol. So the TCP is a standard protocol that allows the system to communicate over the internet. It establishes and maintains a communication between hosts. One thing to note is that transmission control protocol makes sure that every single data that is sent is received at the other end. So we can see the user datagram protocol, which is different from the TCP, is also a transmission layer protocol, and it is an unreliable transport protocol, as in the case the receiver does not send any acknowledgement when the package is received. The sender does not wait for an acknowledgement, therefore this makes a protocol unreliable. So we noticed that when we saw the segment, we saw acknowledgement number there. What that means is that there's a three-way handshake sequence done. So is a communication channel is created that is reliable. But in the case of UDP, that's the user datagram protocol, it doesn't really care whether the receiver has received the data. It just keeps sending. And if there's any issues with the network, it doesn't care. It just keeps sending. So we'll see later the benefits of using the TCP and also that of the UDP. So we can see other functions of the transport layer like service points, addressing, segmentation and reassembly, connection control, flow control, and error control. So you can pause the video and take time to read this and research more about them. So then after the transport layer, we now have layer 3, which is the network layer. So at this point, the segment is taken down to the layer 3 and a layer 3 header is attached to it, which is called a packet. So the layer 3 header with the segment from layer 4 is joined together and it creates what we know as a packet. So we can see the packet itself and we can see the payload from layer 4, which is represented at the right in purple color with the data from layer 7 to 5. So we can see that this process is an encapsulation process whereby an IP header is attached and encapsulates the layer 4 segment to create packets. So we can see that a chunk of data with a network layer header is what we call the packet. So that data, which is the chunk, is from the segment layer 4. Very important to understand. So now we can see that the first bit of the network layer packet is the source IP address. And we can also see that it has the next after that is destination IP address. Then we have time to leave and order, which specifies other things with information added. So layer 3 manages device addressing, tracks the location of devices on the network, whereas layer 4 is involved in making sure that there is end-to-end connection and data is transferred successfully from one end to another. Layer 3 is more importantly based on the IP addressing, so the location of the IP devices. So from the host device location to the destination device location and the nodes that are in between. That's what it's concerned about. So it determines the best path to move data from the source to the destination based on the network conditions, the priority of service, and etc. other factors. So the data link layer is responsible for routing and forwarding the packets. Sorry, this is a mistake. It's actually the network layer, not data link, which is layer 3. The network layer is responsible for routing and forwarding the packets. Routers are the layer 3 devices. They are specified in this layer and used to provide the routing services within an internetwork. So the device we use to identify the locations of other devices and to control the transfer of that data from one location to another are called routers. So the protocol used to route the network traffic are known as network layer protocols. And examples we have of these protocols are IP, which is IP version 4, and IP version 6, which is a newer version. And we can see other functions of the network layer. We explain what internetworking is, which is providing a logical connection between different devices through IP addressing. So we also see addressing, where we add source and destination addresses to the header of the frame, and then we can identify devices on the internet. We also have routing, which is a major component of the network layer and determines the best path, the optimal path out of multiple paths for the source to the destination. So we have packetizing. A network layer receives the packets from the upper layer and converts them into packets. This process is known as packetizing and is achieved by Internet Protocol, which is the IP. So what creates the packets is the process is called packetizing. So then we have layer 2, which is the data link layer, which is also different from layer 3. So the packets sent from the layer 3 is sent to layer 2, and now we have a header and also this time a trailer added to the packet to form a new type of capsule, that is the frame. We call it the frame. So in layer 2 we have the frame. In layer 3 we have the packets, and remember layer 4 we have segments. So this frame is sent down to the physical layer. So we can see in the layer 2, which is data link layer, which is called frame, we can see that now it has first a destination MAC address and then a source MAC address. Then we also have layer 3 protocol, and we also have the attachments to it. So we can see that layer 2 is responsible for the error-free transfer of data frames. It defines the format of the data on the network. It provides a reliable and efficient communication between two or more devices. It is mainly responsible for unique identification of each device that resides on a local network. Now let's take note of this. We have the layer 3, which is the network layer that identifies the IP addressing or logical addressing of devices, but layer 2, which is more involved with the local addressing, has to do with the MAC addressing, not the IP addressing this time. So we can see that this is what we call physical addressing. So the MAC address is the physical address of each device, but the IP address, which is logical address, can be changed for each device. The MAC address cannot be changed. So later we'll see more information on how that works. The data link layer has two sublayers, which is the local link control layer and the media access control layer. Very important. The local link control layer is responsible for transferring the packets to the network layer of the receiver that is receiving. It identifies the address of the network layer protocol from the header, and it also provides flow control. Whereas the media access control layer is the link between the logical link layer, control layer, and the network's physical layer. It is used for transferring the packets over the network. So we can see that logical link control layer is the upper part of the layer 2. That means it deals more with layer 3. So it identifies the header of the layer 3 packets. So it has an understanding of the layer 3 addressing. And the lower part, which is the media access control layer, deals more with the physical layer of the device. So we'll get to understand this more later. So we can also see other functions of data link layer. We have the framing. Remember, it's called the frame. Then we have physical addressing. We have the flow control, error control, and access control. So we can pause this and read through and do more research to find out what these things entail. So we have the final layer, which is the layer 1, which is physical layer, which receives the frame from layer 2, and it gets down to the physical layer, which is simply ones and zeros passing through an electrical cable. So it could be a wireless link, it could be a Ethernet cable, it could be glass, that's fiber optic glass. So whatever means is transferred is meant to have an on bit and an off bit, on which is 1 and off bit which is 0. So that's how it's transferred through that media and is sent to the other end back to the recipient, and it goes up through the OSI model from layer 1 back to layer 7. So we can see that is the lowest layer of the OSI model. The main functionality of the physical layer is to transmit the individual bits from one node to another node. It establishes, maintains, deactivates the physical connection, and it specifies the mechanical, electrical, and procedural network interface specifications. So now we have a summary of all we've explained from layer 7 down to layer 1. And we can see the application basically is the layer that provides the services to the user. The presentation layer is responsible for translation, compressions, and encryption. The session layer is used to establish, manage, and terminate the sessions. The transport layer, it provides reliable message delivery from process to process. The network layer, which is the layer 3, is responsible for moving the packets from source to destination using IP addressing. The data link layer, which is layer 2, is used for error-free transfer of data frames. And the last layer, which is physical layer, provides a physical medium through which bits are transmitted. So let's see another summary to that, and we can see here this one explains the application layer as human-computer interaction layer, where applications can access the network services, which makes sense. Then the presentation layer ensures that data is in a usable format and is where data encryption occurs. Then the session layer, which is layer 5, maintains connections and is responsible for controlling ports and sessions. Transport layer, on the other hand, transmits data using transmission protocols like TCP and UDP, like we saw. The network layer decides which physical path the data will take. The data link layer defines the format of data on the network, and the physical layer transmits raw bit stream over the physical medium. So let's just see one more summary which summarizes it. So we see that application layer provides a user interface. Presentation layer presents data, handles encryption and decryption. Session layer maintains distinction between data and of separate applications, provides dialog control between hosts. Transport layer provides end-to-end connections, provides reliable and unreliable. Remember, reliable is TCP, unreliable is UDP, delivery and flow control. The network layer provides logical addressing, provides path determination using logical addressing. The data link layer provides media access and physical addressing. And the physical layer converts digital data so that it can be sent over the physical medium, moves data between hosts. So that's the basic summary of the OSI model. So let's remember that in layer 7, layer 6, layer 5, the data or the information that has been taken is called data. Then it moves down to the layer 4, which is segments. It becomes segments because remember, layer 4, which is transport layer, header is added to the data that comes from layer 765. Then from the transport layer, it moves to network layer, and the network also adds a header to the segment, which is called the packets. And from there, it moves down to layer 2, which is the data link layer that adds a header and a trailer to the packets to form a frame. And the frame now moves down to the physical layer, and that's when it's converted to bits, ones, and zeros. So that's the best way to understand what the OSI model is. So the second type of model we saw earlier is the TCP/IP model. And in order not to waste too much of our time, just understand that there is very big similarity between the OSI model and the TCP/IP model, but the diagram explains the main differences. So it said the first four layers, which is layer 1, 2, 3, 4, provides physical standards, network interface, and internet networking and transport functions that correspond to the first four layers of the OSI model. So there's big similarity. And the last three layers are represented in the TCP/IP model by a single layer called the application layer. So that's the main difference, is that the last three layer, which is 5, 6, 7, which is presentation, session, and application, is now called the process or application layer in the TCP/IP model. And the first two, which is the physical and data link, is called network access. So they actually perform basically the same types of functions. So we can see a summary of the OSI model versus TCP/IP model. And we can see the network interface, which coincides with the physical and data link. And we can see that from the physical layer, we have wires, radio, and glass, which optic fiber. We have data link, which is Ethernet protocol when you are using Ethernet cabling with switches. Then we have the network layer, which is the Internet protocol, IP protocol, or IP version 6 protocol that is used. The transport, which is TCP or UDP, and transport layer. We also have session, we also have presentation, and application, which is like the website or the email. So maybe later we'll see some of the protocols that we have that function in all these layers and the importance that they play. So that's the basic summary of the OSI model and the TCP/IP model, which are called the network communication models.